beginning, I'd like to rewrite what we're trying to prove in a different format, I guess. This congruent statement means the very same thing as x to the 46th minus 1. There's actually three ways to write this. Is equal to 46 raised to the 52nd. Let me make that 6 a little bit bigger. Yeah, it's 6. 46 raised to the 52nd power times some other integer. In other words, call it k if you want. Call it k or m or whatever favorite integer you want. But anyway, this part right here, what we're trying to prove is absolutely equivalent to this statement that x to the 46 minus 1, and x is just some integer, is going to be a multiple of 46 raised to the 52nd. Now we're given that x minus 1 is some multiple of 46 to the 51. And to avoid clutter, I won't write that down. But if we can reach a statement like this, we'll be done with the problem. Okay. And I'm mixing the congruence notation with the divides notation with just the straight factored form notation. Okay. Now, the given is equivalent to this. 46 to the 51st divides x minus 1. This divides is just another way to write this, just like this is another way to write this. All right, now, since we are aiming at getting to this point where we can say that x to the 46 minus 1 is a multiple of 46 raised to the 52nd, it's very reasonable to consider this statement right here. Here we have x to the 46 minus 1 in this telescoping algebraic form. You can see how everything just cancels out, and all you're left with is x to the 46 minus 1. Okay, now we already know the given tells us that this piece right here is a multiple of 46 to the 51st. So I'll write this directly above it, directly above the factor x minus 1. I'm going to write down that I'm intending to convey that it's a multiple of 46 raised to the 51st power. Okay. And some people don't care about this, but we called it k here. We'll call it m here, although some people just freely reuse symbols. I guess that's okay. Everybody has their own preference on that. So you see, we're almost there right now. You see, we want x to the 46 to be 46 to the 52nd power times some other integer, right? We already have that part of it is almost there already, right? So let's keep going. Now, another big step here that turns out to be quite useful is if 46 to the 51st divides x minus 1, 46 certainly does too. That's trivial, right? So we don't have to worry about that. And this means the very same thing, is that this is equivalent to, in congruence arithmetic or modular arithmetic form, this is congruent to 1. X is congruent to 1 mod 46. Okay, y'all, and again, probably some of you are going to say, why are you switching? It was just easy for me to switch around between the notations here. This is sort of an awkward problem to work all in one notation form, in my opinion. But notice how this part right here, which is important to us, we know what's going on right here with x minus 1. Like I say, we're almost there just with x minus 1. But what about this object right here? Well, congruence arithmetic says you can substitute freely with congruence just like you can substitute freely with equality, right? So you see how x to the 45th gets replaced with 1 to the 45th, x to the 44th gets replaced with 1. That's this 1 that you see right here, all right? But this is equal to 46, okay? Or I should say congruent to 46, because we actually use congruence to get here. Now you can actually say it either way, right? But this part right here is congruent to 46. Okay, mod 46. Okay, so that means that we can write this part right here is 46. And I will put to the first here. we can rewrite this part as 46 to the first, and we'll call it m sub 1. Okay? So you see how we got what we wanted right here? In other words, this is now true, right? Because we have x to the 46 minus 1 is equal to a multiple of 46 to the 51st. It's also equal to a multiple of 46. So that's where this 52 is going to come from. Okay, you see, so we did this statement right here is equivalent to the statement we're trying to prove, and this statement proves that this is true. Okay, and I hope that makes sense. I'm just going to leave it like this and say we're good, because again, this part right here is a multiple of 46 to the 51st, x minus 1 in this factorization, and this part right here is a multiple of 46. Okay, so this statement right here is true. So I'll check off on this. I'll put QED right next to this. And I'm not leaving out too many details, I don't think, but I don't want to clutter the screen with a lot of explanations or justifications for my steps. Hopefully, a lot of you are familiar with modular arithmetic and understand what I did here, and I hope it makes sense, and I hope if you see any mistakes I made, you'll let me know. But anyway, this proves this statement right here. So, and notice how large these numbers are. They are so large you can't really, it's difficult to check for any these moduli are unpronounceable numbers, right? But anyway, hopefully all this made sense. There was essentially 2 steps. The given got us a lot of what we wanted, and we had to do slightly more work. Strangely enough, I didn't notice this simple truth right here. If 46 to a power divides x minus 1, well, 46 has to divide it. That's just the transitivity of divides going on, okay? But anyway, that's it.